Imagine a carbon-free, limitless supply of energy, not dependent on geography or climate, with little proliferation risks and no long half-life radioactive waste. Fusion energy, the same energy that powers the sun and stars, occurs when two atoms combine to form a heavier atom. But for a commercially viable fusion energy plant, research, design, and development is needed to create an operational fuel cycle. That's where Savannah River National Laboratory comes in.
I see Savannah River National Laboratory as this global citizen that collectively looks at improving energy efficiencies and bringing new energy sources to the grid. What Savannah River National Laboratory is exquisitely good at is separation of light isotopes, which is absolutely essential for fusion processes. And because our laboratory is an expert in tritium, deuterium, and hydrogen, those are essential elements that you need for a fusion process.
So it tries to mimic that natural.
Another reason that it's important for the program to ramp up now is because about a year ago, the Department of Energy announced the bold decadal vision for fusion to have a pilot plant for fusion within the next 10 years. And it's essential that we develop those technologies, get the technologies ramped up and designed now in time for a pilot plant.
To help realize fusion energy commercialization, SRNL researchers are advancing technologies, materials, and process efficiencies in the deuterium-tritium fuel cycle.
In the fusion program, we have a very diverse fusion technical team. We have physicists, chemists, engineers, scientists, we have PhDs, masters, bachelors, and all is needed. And it has been very exciting to put all of that together as a program and work towards the whole vision that we want to how to bring fusion to the US grid.
SRNL performs fusion fuel cycle modeling to optimize system design, monitor operation, control the process, and simulate performance.
You can guide experiments, you can guide design decisions for experimentation to start getting this information to improve your models and improve your ultimate design decision on the back end. Because you want to try and get as close to the final design as possible when you build your pilot plant.
Developing and characterizing durable materials that can be exposed to hydrogen, deuterium, and tritium is another challenge in the fusion fuel cycle.
So we are trying to understand how tritium affects the properties of different materials, and also how it moves through materials and where it gets trapped when it is moving through those materials. So we can understand how we can contain it and avoid environmental release.
To reduce costs and improve energy efficiency, SRNL developed a patented process cycle to detritiate pump oil in common vacuum pumps.
We're trying to find ways to adapt existing commercial pumps and make them work for fusion energy. So we're looking at the molecular structure of oils and trying to find the ones that work best with tritium, because tritium is very destructive towards its materials. So we're actually using organic chemistry to support fusion energy in that way.
SRNL is also leading the development of the tokamak exhaust process for ITER, the 35-nation collective demonstrating grid-scale fusion feasibility in France.
ITER is potentially a historic project. It's the first large-scale machine to prove that power can be supplied to the grid from a fusion device. Also, workforce development and the future fusion community is being developed through the interactions and design efforts being made on the tokamak exhaust process. We're developing the future for fusion.
Outside of the SRNL campus, the fusion team is collaborating with companies, universities, workforce development partners, as well as other DOE national laboratories. The unique resources at DOE's Savannah River site, which includes pre-approved tritium inventories, exceptional site characteristics, and defined environmental analyses, can also further fusion commercialization.
I think the opportunities here at Savannah River are limitless. I think there's opportunity to actually build big things at Savannah River. We have 300 square miles of government property here where we can locate nuclear facilities such as a fusion energy demonstration plant. Big laboratory capabilities for testing new components for nuclear fusion.
Fundamentally, the laboratory is really the birthplace of a fusion fuel cycle. But what makes all of that great is the people that work on those projects. We got bright scientists in early career, mid-career, and senior scientists with vast subject matter expertise, all working as a team to solve this very complex problem that affects our nation as a whole.